Section 4. Categorizing text documents. In this section, we're going to recap supervised learning. We're going to describe the news corpus that we're going to use as our example. We're going to cover building classification pipelines in scikit-learn. We'll look at how we can optimize these pipelines using grid search to give us a better accuracy. And finally, we will talk about extensions of this project and how you can deploy our learned model in a live production system outside of our notebook. Supervised learning refresher. In this video, we're going to take a look at supervised learning and recap some of the gotchas and some of the key concepts. And we're also going to describe our news corpus. This video will be split into two parts. Let's begin with a definition of supervised learning. Supervised learning is the process of training a statistical model, also known as a classifier, to accurately predict the class of an observation based on a set of measurements. There's a few key terms in here that have very specific definitions within supervised learning. Features are numerical or sometimes categorical measurements for each example or each data point. Labels, also known as classes, are a discrete number which describes the category of the training example or the data point. A classifier is a trainable model that learns some function to map those features to those labels. This will become a little bit more concrete if we consider an example from outside of text processing. Let's imagine our task is to predict whether some transaction is fraudulent or not. This is something that a lot of credit card companies do all the time. In this case, your features for each transaction might be the amount of the transaction, the hour of the day that it takes place, and the type of purchase. Is it online? Is it in a store? Or so on. And then the class would be either fraudulent or not fraudulent. So at a very high level, the process for supervised learning, or for classification rather, is as follows. We have some input feature vector, which is fed to our classification model, and we get some prediction out. In this case, it predicts class 1. But actually, there's a 0th level step, which is very important here, which is to go from our raw data to our feature vector. And I've also glossed over exactly how we get to our classification model. And in fact, these 2 points are among the most important. So the process of going from raw data to a feature vector is known as feature engineering. And if you're dealing with numerical data, that's normally a fairly straightforward process. If you imagine you have something like sensor data, so measurements of temperature and humidity, these are already in the form of numbers that you can quite easily massage into a feature vector. In the case of text, there's lots of different choices you can make as to how you convert that text into features. We've discussed some of those in the first couple of sections, and we'll look in more detail in our example notebook about how we can deal with those choices. The other important step here is the model training. How do we decide what that classification model is, and how do we find that function that maps between the input and the output? That process of model training is something that is basically an optimization process that needs to be iterated through and gradually improved.